Hey guys, I'm going to start this video with a summary of what we talked about in class. So first, we talked about finding the equation of the tangent line at x equals c. Remember that for calculus, we use the point-slope equation of a line. So in order to find the equation of a tangent line, you first need the slope, which you'll find the slope by doing the derivative, because the derivative of the function is the slope of the tangent line. That is the slope of the tangent line. We will then evaluate the slope at x equals c, whatever that value is. We also need, and that's our slope of our tangent line. And then we also need the point of tangent c, which could be found by using the x value and then the y value. So evaluating the function at c. So c comma f of c, that's our point. And then we will use point-slope form. So at that point, you have your slope of your tangent line, you have your ordered pair, or your point of tangency, and you can write the equation of your tangent line. The next thing we did was the equation of the normal line, and you're almost going to follow the same format, except you need to know that the normal line is perpendicular to the tangent line. So we'll find the normal line at x equals c again. You need to find the slope, which is, the slope, which is the derivative. That's going to give you the slope of the tangent line. You want to evaluate that at c. That's the slope of your tangent line. And then you want to do the opposite flip, so the negative reciprocal, since the normal line is perpendicular. So the negative reciprocal is going to give you the slope of your normal line. That's the negative reciprocal of f prime of c. That'll give you the slope of your normal line. Because again, the normal line is perpendicular to the tangent line. So it's really just taking the slope of the tangent line and negative reciprocating it to get the slope of the normal line. And the last thing, and very important thing we did, was find values of x at which points, we're finding at which x values the function f of x, where does f of x have horizontal tangents? So where does f of x have horizontal tangents? The function f of x has horizontal tangents where the derivative is equal to 0. If a tangent line is horizontal, then the tangent, the slope of the tangent, is 0. If the tangent line is horizontal, the slope of the tangent is 0. What that means is that the derivative is 0. And once you find the derivative and set it equal to 0, you will then use algebra to solve for x, to find the x values at which the function has a horizontal tangent. So now we're going to move on to the notes. This is the last page of Lesson 8 notes. And we're going to go ahead and take a look at derivatives by table and higher order derivatives. So let's start by taking a look at this. Use the chart to find f prime of 3. So this is called derivatives by table. And it's really important to know this skill. This was actually one of the, this was part of the FRQs last year. One of them had a derivative by table component to it. Anyway, okay, so use the chart to find f prime of 3. All right, so here's the question. And you see kind of a lot of gobbledygook mess here. Well, in order to find f prime of x, I have to tap into all of my differentiation techniques. I see here that 4 is multiplying to g of x, so the derivative is 4 times g prime of x. Basically, the derivative of g multiplied by the constant 4. Same thing here, minus 1/2 h prime of x. I don't care what h of x is, but I know that whatever the derivative of h of x is going to get multiplied by that constant. And this is 1, and the derivative of 1 is 0, so I'm not even going to write it down. So f prime of x is equal to constant coefficient 4 times g prime of x minus constant coefficient 1/2 times h prime of x. Since I'm looking for f prime of 3, I just need to plug 3 in to this equation, because this is what f prime of x is equal to. So f prime of 3 is going to be equal to 4 multiplied by g prime of 3 minus 1/2 multiplied by h prime of 3. And if you look at the table, you have g prime of 3, so you can just plug it in. and you have h prime of 3, so you could just plug it in. So f prime of 3 is equal to 4 times negative 2 minus 1/2 times pi, or negative 8 minus pi over 2. Negative 8 minus pi over 2. That's f prime of 3. Let's do the next one. All right. Oh, that's a regular function. You won't need the table. So f prime of 3 is equal to, well, f prime of x is equal to 4x to the third minus 8x. And then f prime of 3 is just plugging 3 in there. All right, let's do one with the table. Let's look at D. All right. So to find f prime of 3 for D, first we have to find f prime of x. And if you take a look, this is a quotient, so I will be using quotient rule. Quotient rule is low D high minus high D low over low squared. So f prime of x, let's make sure we have the chart there. F prime of x is low multiplied by D high. D high is the derivative of that difference. Remember? The sum and difference rule. The derivative of the difference is a difference of the derivatives. So basically g prime of x minus h prime of x. So there's low d high minus high, let me get some space here, minus high d low all over low squared. So let's double check. Low d high, g prime of x minus h prime of x, minus high d low all over low squared. And guys, the rest, since we're looking for f prime of 3, and this is what f prime of x is equal to, f prime of 3 is going to be equal to taking that x value of 3 and putting it here, 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 and here, and finding those values in the chart. G of 3 is 4, g prime of 3 is negative 2, h prime of 3 is pi, and so on and so forth. It's just at this point, plug in values from the table. Plug in values from the table, and then just follow the order of operations. So I'm going to go ahead and set up this last one. This is also looking like it's going to be a quotient rule. So f prime of x is equal to low d high, g prime of x, low d high, minus high d low, which is 2h prime of x because of that constant coefficient. So low d high minus high d low all over low squared. I'm just being very careful. I'm putting a lot of grouping symbols to make sure I keep everybody nice and grouped together. There is f prime of x. They wanted us to evaluate f prime of 3. So we take that x is 3 and plug it in to f prime of x and use the table to find those values and then do the order of operations. Last thing I want to briefly talk about is higher order derivatives. What we've been taking is the first derivative. F prime of x is the first derivative, and f prime of x is the slope of the tangent line. Okay? F prime of x is the slope of the tangent line. Now, the instantaneous rate of change, slope, instantaneous velocity, slope of the tangent line, derivative, it all means the same thing. Higher order derivatives is like saying, okay, the second derivative is a higher order derivative because it's the derivative of the derivative. So when you find the first derivative, you could take the derivative again, and then you found the second derivative. What it means, we'll learn about later. What does the second derivative mean? What does the third derivative mean? We'll learn about that later. But for now, actually we only talk about the second derivative in this class, but for now, you may be asked to find the second derivative or third derivative and so on. So you're just basically taking derivatives of the derivative. And the notation is hash marks. The number of hash marks tells you what derivative you're on. So if we want to find f double prime of x, if we want to find the second derivative, we're looking for the second derivative. First we have to find the first derivative. Okay, so first derivative is 8x squared minus 10x, 8x squared minus 10x minus 7. That's the first derivative. What's the second derivative? Well, do it again. F double prime of x. Derive again. Take the derivative of the first derivative, and that's equal to 16x minus 10. And there's f double prime of x. So hopefully that will help you with the following. You're just taking the derivative of the derivative, and that is my video for you. Your homework is the lesson 8 homework, which we've been working our way through, and your job is to finish 28 through 45 all. Please do your homework. Please practice. It is imperative that you try every problem. Do not skip. You're only going to get good at this if you practice. See you tomorrow.